We're here with Daniel Reed, or Dan. Do you go by Dan or Daniel Reed? What do you prefer?
Dan is fine.
Dan. We're here with Dan Reed from Laceworks, and he's here to talk to us about container and Kubernetes security at scale. So before we begin, we just have a quick poll as to where you are at in your Kubernetes journey. So if you want to answer that, it just helps us kind of make sure that we're giving you the presentation best suited to where most of the people are in your journey. Just give a minute for that. And if you've just joined us, we're running a poll now just on where are you on your Kubernetes journey. So answers to the poll, we have about 50% of people on the call who are learning about containers and Kubernetes. And then about 50% of the people have a test cluster that they're running. So your speakers today, so I'm Danielle, I'm hosting today's Kubernetes clinics, but we have Daniel Reed. Daniel, do you want to introduce yourself?
Sure. Yeah, absolutely. So I'm Dan Reed. I actually run our sales engineering team here at Lacework. I have background as far as enterprise software is concerned. I've been doing this for about 15 years between BMC software and Datadog. So I specialize in automation, enterprise monitoring, and now cloud security, really cloud native service security. So I'm glad everybody could join us today. It's nice to meet everyone.
Great. So just a quick thing about Fairwind. So we're bringing you today's Kubernetes clinics. We are a provider of software and services for Kubernetes. So our software helps you check that you've done Kubernetes right. So you haven't messed up any configurations to let any security vulnerabilities happen, or you're not wasting any money. We have a wide array of open source tools that we use for our services, which is a fully managed Kubernetes service. So that's us, and I will hand over to Dan to run through his deck.
Sure, and let me go ahead and share my display here. We'll get started. So to get started with, just scroll ahead here. So really what we want to do is we want to get started with in terms of the state of containers in the wild, and talk through kind of where a lot of organizations are in terms of their Kubernetes adoption and their containerization strategy. We'll also talk through some of the security problems that have become very apparent in a containerized world. And then finally, really understanding how certain things can happen from a build time perspective and runtime security in Kubernetes to ensure that workloads are being protected, both on premise as well as in the public cloud. So we're going to cover all these things in depth. I'm going to go through an agenda. I will show you a brief demo at the end as well. We should have time for questions, and we should be able to talk to the audience a little bit as well. So let's go ahead and get started. So the state of containers in the wild. So the long and the short of it is that the adoption around containerization has exploded really in the last 4 or 5 years, right? And what we're seeing within enterprise architecture is that the level of adoption has started really obviously in development environments, and a lot of folks are starting to put workloads in containers starting back in 2016 or so. And really what's happening now is that there's been a significant jump into production types of workloads. So folks are now beginning to trust containers as a technology. This is actually a survey that was done in the Cloud Native Computing Foundation survey in 2019, but this is valid today, where we're seeing a significant uptake as far as containerized services and particularly around orchestration frameworks in Kubernetes and in other areas. So that's one of the areas that we're seeing significant areas of emphasis as far as enterprise is concerned. In addition to that, we're seeing that the scale associated with these containers are exploding. So, a lot of workloads, back 4 years ago, we're running in a lot of sandbox environments, and we're really not running with the elastic scale in mind. But now that more and more production workloads are running as far as containerization is concerned, You're seeing more services that are running in the context of container. There's more containers per service. And finally, more users are actually utilizing the services that are running as containers in the front end. And you see this, this scale being facilitated by really the ability to utilize cloud native services within AWS or Azure GCP. You're seeing that within orchestration frameworks, within Elastic frameworks that Kubernetes really can expose within either hosted solutions like EKS or on-prem solutions that you can run inside a Rancher or something like that. So, a lot of scaling is happening that's actually elastic in nature, where the workloads are being built out in a fashion that's native from a cloud perspective. So some of the major problems that we see as far as containerization strategies are concerned are really, they fall into three buckets, right? There's cultural norms that really are involved with how, most organizations have, gone after virtualization initially, now are moving to cloud native related services. And a lot of the cultural shifts are related to how DevOps cultures are being built out and some sort of the new CI/CD processes that are in place in terms of security. Security is obviously top of mind, particularly when we start talking through elastic scale. You have the ability to perpetuate a security-related issue across lots and lots of resources and do so very rapidly. So that's obviously top of mind for a lot of organizations. And then finally, the complexity associated with these environments. So you're adding an orchestration layer in place that orchestrates the deployment of certain things. You have cloud services that are native in nature. That obviously introduce significant more complexity. So gone are the days where you can kind of manage things in the four walls of your data center. It's really come down to how well you manage this complexity from a DevOps perspective, as well as a deployment strategy. So what I like to talk about, and where we start to focus from a Lacework perspective, is security and in parentheses and other problems. So where we really start to begin our conversation, this is actually according to a 2020 survey of an organization called 451 Research. And this is really very focused in terms of how different misconfigurations in Kubernetes, as well as different vulnerabilities within the context of the containers that are running there, have caused a significant amount of impact as far as security operations organizations. So, of the organizations surveyed, 69% detected some type of misconfiguration. So this could be something simple like kube proxy was misconfigured. It could be something simple like, certain ports were misconfigured. It could be a variety of different security group misconfigurations as well. The vast majority of organizations have detected some type of misconfiguration. This is actually resulting in a significant amount of runtime security incidents, right? So over a quarter of those organizations surveyed had security incidents that were directly involved with or related to configuration-related problems. So, they're seeing this propagate itself in production environments at this point. And then finally, one of the areas, just about a quarter of organizations surveyed had significant vulnerabilities with which to remediate. So as you're introducing things in containerized environments, introducing different packages at different layers, and really understanding both the vulnerability nature of those containers as well as the host that they run on, a lot of organizations are still struggling with vulnerability management programs and really how to address those things at scale. So what the end result of this is, the vast majority, almost 100% of organizations reported a serious security incident involved with Kubernetes or other containerized environments. And that's really as a result of what we talked about in terms of the shift in cultural norms, the shift in the DevOps pipeline. There's a variety of different things that are really affecting that from an overall perspective. So if we take a look at really how container security needs to be handled, and the way that Lacework is helped with this in practice is really, we've addressed this as really a big data problem, right? Rather than looking at rules and policies and trying to fix, and prohibit certain things from happening, it's really around understanding the complexities of how these environments are being deployed. So to get started with, there's multiple different users of containerized services, everything from the engineering resources to the DBAs to different compliance activities that have to happen on there, being deployed in multiple environments in a lot of cases. So you have complexity there. In addition to that, you have CI/CD pipelines, which are rapidly deploying microservices onto cloud native services, and they're doing so at massive scale. You're talking not in the order of ones and twos in terms of the hosts that were supported, but really hundreds and hundreds of containers are being deployed as far as microservices are concerned. And really, this is exacerbated by the problem where you have a lot of these things that are happening in auto-scaling types of compute and containerized services. So, Kubernetes clusters provide a significant amount of flexibility as far as that's concerned to provide workloads that are directly tied to the load that's being encountered by a particular application. But it also can propagate vulnerabilities very quickly across the environment. So, in general terms, what this really results in is that it's generating a lot of data. It's generating a lot of things that we need to look at, both from a service context perspective, as well as the Kubernetes backplane, as well as understanding what vulnerabilities are being exposed in customer environments. So you're talking about a significant amount of change being introduced, and constant change really in terms of these CI/CD pipelines. But really the amount of security personnel and staff that are focused on this rate of change, it typically doesn't change, right? And their security related talent is finite in nature, and it's really hard to find engineers, cloud, especially cloud focused engineers that are security related. So these unchanged vectors are really what's exacerbating the problem as well. So the causes of this in terms of, and as I mentioned around the security components, there's really three major things that play into the major problems that we're seeing as far as that 94% of incidents related to Kubernetes and containerized services is related to three major areas. So first of all, understanding the vulnerabilities. So understanding what vulnerabilities are being introduced at each individual container, understanding at what point in the DevOps pipeline those vulnerabilities are introduced, as well as what's running in production as far as the vulnerabilities are concerned. So that encompasses a big chunk of it. If you look at something around SOC 2 or ISO compliance or even PCI and NCIS, the ability to address vulnerabilities at scale becomes a major blocker for a lot of organizations. Containers, because they are being developed very rapidly and organizations are embracing that technology, it's not like addressing vulnerabilities on individual hosts anymore, because you really have to address all of those container images, of which could be changing on a daily or even hourly basis. Some of the other things that we're seeing too is in terms of behaviors. So containers are designed and are purpose built to perform in a certain manner, right? They're designed to expose services in a method that provides that service through a distinct set of ports. It's going to interface with certain endpoints. It's going to interface with other parts of our ecosystem from a workload perspective. Understanding those behaviors and what normal is inherently important to protecting the security components. And then finally, cultural. So as I mentioned, with the DevOps culture, with the rapid deployment and the velocity that organizations are actually adhering to, these other two things become inherently more important, because the fact that you're developing things in a pipeline, application developers are building code rapidly and supporting new and fancy services, and at the same time, security has to be part of that DevOps process. So let's start, and we're going to unpack this a little bit in terms of where we see the most impact. And when I start talking about vulnerabilities in general, really there's three major things that we need to look at from an overall perspective. So the distribution of vulnerabilities in terms of where those things sit, the propagation when things scale elastically, and finally the detection in terms of understanding what vulnerabilities are introduced in the pipeline as well as what's in production. So these are three major areas that need to be addressed from an overall vulnerability management program. So really for individual CVEs that are introduced at individual layers at the container level, understanding what that threat vector looks like, and really understanding a couple of things. There's a big difference between a vulnerability and having a vulnerability in a container and actually being vulnerable, right? So if a particular package is not used in a service context, as an example, or if it's not actually in use from a platform perspective in any way, shape, or form, you're not actually vulnerable, and you can prioritize differently based on that. So the way that we've attacked this problem is we're really looking at the things that have significant service impact, we've also looked at things that are running in terms of the vulnerabilities that are resident out there. So we've checked it into repo, or we've actually scanned at build time from a vulnerability perspective, and we're understanding how many containers and how widespread this particular vulnerability is. So the propagation and detection components of it. So that's really what we would focus on when you think about container build time security. So making sure that as you're building a Docker image, or as you're putting something together from a services perspective, that you're protecting, what those things are that are going into that build. And you can do that, as part of your CI/CD process. You can do that in terms of actually validating the manifest and making sure packages that are being introduced are not introducing vulnerabilities at large. So the second thing the second vector that we look at from a containerization and Kubernetes perspective is really behaviors, right? And how we model that. So one of the key areas that Lacework is exceedingly good at is actually understanding how users are interacting with containerized services. So really the containers that are running in the context of pods, that are running in the context of individual Kubernetes clusters, really understanding those interactions and those behaviors at a very granular level and baselining that activity. So this is where it's very interesting to understand not only the container build time aspects that I talked about in the vulnerability management program, but really the runtime aspects. So as containers are running and they're supporting services in an environment, what the connectivity looks like as an example, or what other services are being interacted with by the rest of the environment, and really having that understanding of network awareness and the communication paths, and having overall observability into these environments is inherently important to protecting the security of it. And I'll show you how we do that in practice. So finally, in terms of cultural shifts. So one of the biggest things that we see as a major gap as far as the cultural shift is concerned is that the development teams and the security teams in a lot of customer situations don't have a great relationship, right? The security teams are typically seen as the office of the no, and they're actually trying to prevent certain things from happening based on what they understand to be the security vectors and some agreed upon criteria based on that. That causes all kinds of friction associated with the culture within an organization. So DevOps teams want to move fast. They want to deploy services more quickly. They want to get code out the door. But at the same time, the security teams have to manage that. The security teams have to make sure that the code that's being deployed within the context of containers and Kubernetes is adhering to specific standards. So the way that we address that from a Lacework perspective is we provide a single sheet of music to read from, right? For both the development teams as well as the security organization to utilize. So that means integrating into the DevOps pipeline and actually doing build validation. It also means sending really highly contextual events for when something does happen in an environment and it's outside of behavioral norms, to make sure that those communication paths are open. So very frequently, culture has very little to do with technology, and it has everything to do with the ability to communicate across functional business units. So that whole managing of that perception in terms of the security team doesn't need to be the office that know, but they at least have to have the fluidity to have the conversations around why this thing that is being done in this environment is bad and why it actually has security implications. Lacework goes a long way to actually provide that at scale, and I'll walk through why that's the case. So that shift in cultural norms and actually how these teams communicate, breaking down that silos to aid in that velocity and the communication paths that are between them is inherently important to any good security posture. So build time versus runtime. So very typically, build time security is, if you only see this half of it, it's very difficult to manage security at scale. And that's primarily because of the way that code is developed, right? You have different aspects of things that are happening within the service context. You're building those things through CI/CD pipelines like Jenkins or Circle CI or Azure DevOps, whatever it may be. And then you're running those containers in context, right? You're running it in EKS, you're running it in Rancher, you're running it somewhere in your environment from a Kubernetes perspective. A lot of times the traditional security methodology is that once it's running, security starts to look at it, right? And that it starts to become important when it's actually running in production. The objective, though, is to start shifting these things left, right? Is to start understanding the vulnerabilities that are actually being introduced and understanding what services are doing earlier in the DevOps pipeline, because that really If you do that in the correct manner, you can start to accelerate how fast you can deploy code as making security part and parcel of the DevOps pipeline. So the traditional methodology around build time security and actually making security figure it out at runtime is inherently broken, right? Because a lot of stuff cannot be caught by runtime. Really, you have to have both. You have to understand what's happening in build time, what's being introduced from a vulnerability perspective, but also understanding how that thing is supposed to operate in production. So if you take a look at runtime security, it's really understanding kind of what that workload is supposed to be doing. And Lacework is kind of uniquely positioned in terms of doing a dynamic baseline on that workload. So that container that's running, it's supposed to communicate within certain paths. It's supposed to understand, or it's supposed to talk to certain services and really figure out where those things are running from a vulnerability perspective, as well as understanding the behaviors of the different services that are being exposed. So the idea is that within runtime security, we can use our big data analytics on the back end, actually understand these behaviors and look for anomalies associated with it. So rather than writing policies and rules to protect against certain leading indicators that the industry has agreed upon, we're really just looking at differences associated with how a particular organization is operating within the context of containers.
Dan, we have a question from one of our attendees that says, what is your competitive advantage when compared to other vendors who do shift left?
Yep. So in particular, there's a couple of things that we could talk about there. I think that the competitive advantage, first of all, Lacework has exposed itself to make the platform accessible via the CI/CD pipeline very readily. So we do that through having a very firm grasp on things like Terraform, having CloudFormation templates, having automated principles with which to deploy our software. But we also allow access to all of the data that Lacework exposes as a platform within that CI/CD process. So as an example, running a dynamic scan against a build manifest for a particular container, or ensuring that a certain configuration meets with compliance, as an example, or meets with CIS best practices. We've exposed the platform in such a manner that you could actually build that into your build process. And we've done that through things like a Jenkins module, or you can do that through a REST API call, even command line utilities, which we expose. We try and bring this level of inside information to wherever your developers are currently working. And that's really a competitive differentiator for us. That's the first piece of it. And then the second piece is really how we actually handle runtime security from an overall perspective. So again, we don't have any rules or policies to tune within the product because we're really utilizing the data that's at our disposal to look for anomalies associated with containerized environments. So I'll show you what that looks like in practice. So the two things there, the accessibility of the data and the ability to interface with your current CI/CD process is one thing. And then what do you do when that thing is running? And how do you protect the context around it when it's actually running in production? Okay, so this is actually a study that was done. This was done by at the IEEE. So it was around container vulnerability and exploit detection. This was in 2019, but really they took 28 real-world vulnerabilities in 24 commonly used server applications to show, to look at those vulnerabilities in container images, and really the legacy types of tools were only able to detect in practice like 3 out of 28 of those vulnerabilities in terms of what's actually running in those particular container images. Really what the net of this is, in order to have a firmer detection methodology, you have to look at both. You have to look at both the vulnerabilities and the CVEs that are introduced to that container image, and you have to look at the build or the runtime components of it. So the level of efficacy went up significantly when you start talking about looking at both halves of it. You're looking at both the vulnerability exploits from a behavioral perspective, as well as looking at the vulnerabilities that are introduced in code. So 86%, 24 out of 28 vulnerabilities were detected in practice. So the idea is you protect what you're building and you also protect what is running. And by doing so, you can get a really firm grasp from an overall security program perspective in terms of the overall visibility there. So the net of this is that Lacework does both, right? At the build time, we can shift left. We can actually start to protect these things as it's going out the door within your CI/CD process, protecting the critical vulnerabilities that are being introduced, both the fixable as well as the understanding the unfixable things. And then at build time, really understand the behaviors, chunking through that large data set that I mentioned around the containers and the services that they're exposing and all the context that they're running in, and being able to understand these behaviors at massive scale, like bigger than any other vendor today. So before I jump into the demo, I guess, are there any questions from the audience specifically outside of the one that we just got?
There's two. So, and I'm going to butcher this question. Which criteria do you fall in? SAST, DAST, IAST? I don't know how to say it.
Which criteria? So the way that the platform is exposed from a Lacework perspective, it is 100% software as a service. So the way that the platform is exposed to our customers, the only software that's maintained and controlled on a customer site is really any agents that we have that are running in the context of Kubernetes. So the way that that works is there's a daemon sets deployment. We can either do that daemon sets deployment through a daemon set, or we can do it through a Helm chart. Our containerized agent facilitates that level of visibility in the runtime detection pieces of it. As far as build time is concerned, again, you can interface with the platform any number of different ways to actually send us a container manifest associated with that build time XML. You can also look at things like ECR repositories and actually scan the images that are checked into registry, that type of information. I think I'm going to answer the question the same in both contexts. So the service is offered entirely in the public cloud. So does the Lacework agent run as a sidecar container within Kubernetes pods? It runs, yes, that's correct. No, so no, it doesn't actually run in that context. So as a daemon sets deployment, the way that it works is that when we initiate the kube control and we deploy our config from a Lacework perspective, you will have a Lacework sidecar that runs per node within your Kubernetes cluster. So for each Lacework agent container, you will have a 1-to-1 ratio with the nodes that are facilitating your Kubernetes environment. So it's not really a sidecar from a pod perspective, because you don't have, like, you're going to run hundreds and hundreds of pods in Kubernetes. We don't have to run hundreds and hundreds of Lacework agents to facilitate those pods. It's really a 1-to-1 between the node and between the Lacework agent. You're welcome. That's really funny. So I guess, Danielle, is there any other questions or anything else that I can cover before?
Nope, there's no questions I see at the moment.
Okay. All right, great. So I think in the next few minutes here, really what I really want to go through is what we can do from an environment perspective, and kind of why we're different in terms of how we protect these workloads. So to get started with, the way that I like to describe Lacework is that we are fundamentally a data platform, right? The way that we understand data at scale is how we facilitate security-related use cases. And the way that we do that is via something that's called the polygraph, right? Basically what the polygraph is a graphical representation of a data set. So that could be what my Kubernetes environment is doing. It could be what I'm doing in CloudTrail. It could be what individual machines or compute resources are doing. It's a way to represent a large data set. And really what Lacework is doing is we're understanding this data set from the context of behaviors. So a behavior might be, all right, I am connecting to a particular service via this IP. This particular service is then making a DNS call outbound and it's talking to an S3 bucket. That's a behavior. That's something that I'm seeing end to end. The reason why we're a little bit different is because we are understanding these behaviors at a very atomic level. So the interfaces with kube proxy, the interfaces between individual pods that are running in Kubernetes, actually understanding all of those behaviors at a large scale. We're understanding all the attributes of those behaviors. So as an example, if I'm doing a Slack notification to a channel and I'm doing so through kube proxy and I'm using root access credentials to do it, that's a behavior that I see in a particular environment, and I can actually baseline that behavior and understand whether that's new, different, changing, or most importantly, malicious in nature when we take a look at Kubernetes workloads. So what you're seeing here is over the course of an hour, you're seeing really a data set, right? We're looking at pod communication that's occurring between the 11 and 12 p.m. hour. Now, this is at the top level. We can look at this thing and you can see the size of this data set. You're looking at lots and lots of pods, lots and lots of containers, all kinds of different traffic that's flowing across all of these things. And really what Lacework is doing is we're understanding this level of complexity, right? So as an example, if I wanted to sort this out and I wanted to look at all the external communication things that are happening. So I could filter this down. Here's all the known bad external IP addresses that are connected into my Kubernetes environment. Here's all the outbound connections that are being made to different AWS services as an example. Here's the interfaces with the kube system and kube proxy. So I can really understand at a very granular level what's happening in a particular environment, right? So the idea is that every single hour, the way that Lacework is basing this information is we're doing unsupervised machine learning to understand these behaviors. So as things are changing in this environment, new pods are standing up, new communication methods are being established. I'm inspecting that with my machine learning. I'm looking for indicators of compromise based on that. So this is fundamentally different than the way that most container and cloud security products are going to operate. Most of the cloud security products that are on the market today have operated in a manner of building rules and policies tuned to leading indicators. So if I sudo access within a particular machine, or I access kube proxy in a particular manner, or I violate some policy, I'm going to send an alert on it. The problem with that is that most developers don't play by the rules. And those solutions tend to be very noisy in production, where you have to spend a lot of toil and a lot of time actually tuning those rules from a security context perspective to actually understand what developers are doing and how they're exposing workloads. So the idea here is that I'm looking at all of this traffic. I'm actually understanding this at a very atomic level, and I'm baselining this hour over hour, day over day, week over week. And I'm really looking at this large scale data set for like 180 days worth of different behaviors that are happening in the environment. So if I stand up a particular container, I understand that this container exposes itself on certain ports, it exposes certain applications, and it has certain communication paths associated with it. And if it ever differs from that, if as an example, I start mining Bitcoin in a particular container, then I can actually see that. I can see that as a known indicator of compromise. I can root that out as malicious type of activity. So when you look at this thing from an overall perspective, you can trend this over hours. Like everything that happened in the purple time frame is things that happen between 10 and 11. Everything that happened in blue is the things that happen between 11 and 12. So the idea is that fundamentally I'm doing a diff across all of these environments. I'm looking at all of my containerized infrastructure, and I'm really understanding what's changing in these particular architectures. So you can see here that, everything that happened between 10 and 11, as I mentioned, is in purple. Everything happened in between 11 and 12 is in blue. And I'm looking at these things over a long period of time. You're talking in the order of not just hours, but really days. And I'm actually trending these things together. And if you don't believe me in terms of the level of discovery that we're doing, if you scroll further down here, you're going to see all kinds of information in terms of the namespaces that are being exposed, the running pods, all of the external communication paths associated with those pods, all of the activities associated with it, the amount of traffic that's being egressed from an individual pod. So the level of discovery is extensive here. One of the key things, though, that I mentioned in my presentation is that it's not just about understanding what the behaviors are around your workloads. It's really understanding where the vulnerabilities are in the context of these workloads. So as I mentioned, we can look at all of the active containers, every single pod that's running a container, and really understand what vulnerabilities are being exposed by these particular containers. And that plays into our vulnerability management solution. So as containers are running, as they're being pushed out the door as well in DevOps process and shifting left in terms of that approach, we can start understanding these vulnerabilities at scale. So I can see there's critical vulnerabilities exposed here within this Helios container as an example. And there's different things that are happening in this environment, both from a critical perspective as well as fixable vulnerabilities. And I can report on all this information. I can start to understand and prioritize, okay, well, this developer, there's 658 unique vulnerabilities as far as this particular container image. This is happening across multiple environments that are running this particular container. I can start to focus in and figure out, all right, well, which one of these are fixable in terms of this environment? Or, all right, let me just look at the criticals and highs and start to sort out where these vulnerabilities are being introduced at and actually get a good handle in terms of, all right, this is a fairly insignificant fix. It's a minor revision as far as the Linux kernel is concerned, or this is a more substantial fix because all of my stuff runs in Perl. And you can start figuring out, like, where you need to place priority, and you can utilize this in terms of your deployment framework. So as containers are being built, you can utilize the build manifests. You can send that data to Lacework. Lacework will assess it and give you a vulnerability report associated with it. You can also scan things like things that are in your ECR repos or in your GCR repos or in things like Artifactory or wherever you're storing these container images. We can scan those vulnerabilities at rest and start to assess kind of the nature of those vulnerabilities at scale. So there's two different things there, as I mentioned. You have the ability to interface with your CI/CD process, utilize the vulnerability management information. Then you can utilize what we do at build time or at runtime from that perspective to understand kind of the things that are happening in these Kubernetes environments and actually how those behaviors are happening. And then the last thing is really what I mentioned around the cultural shifts, is really understanding and having a common framework to notify developers or notify those that are on the technical side to understand what's happening in an environment. So as I mentioned, the way that Lacework generates its data and the way that we understand these environments, the way that we actually generate events when there's a security problem is based on that level of analytics around the behaviors. So by doing so in that manner, we have a significant level of context that we can provide both back to the app dev teams as well as the security engineers to actually triage something, to actually understand what the problem is, where that problem resides, when it was first seen, what application was involved, what machine, what container, what process, all that good stuff. This level of context is inherently difficult to get to if you're trying to do this with something like Splunk as an example, or you're trying to sort this out through looking at Kubernetes in and of itself and trying to do that investigation. You're going to have to hit a lot of different points in order to get to this level of data. So the idea here is that Lacework, for all of its events, whether it's a compliance event, whether it's something that's happening in the containerized environments, whether it's something that's happening within another type of workload, we have a common framework to actually triage and address these things. And we can route these things effectively based on that. So this particular one is potentially nasty, right? We have a cryptocurrency miner that's running in Kubernetes. XMR Ring is a known miner. It's a known miner that's actually running cryptocurrency. So we're going to give you all these levels of context. We're going to see, what application was involved in this, what machine was actually running this particular thing, what the executable path was associated with it, when the first time it was seen and when the last time it was seen, in terms of all the detail that you're going to need to triage this thing and actually shut it down if necessary. So in addition to that, this is the polygraph, right? The reason why we triggered this particular event is we saw this application making an external DNS call to TurtleCoin. Right, so that kicked up a bad DNS address location on our systems. So we knew that XMR Ring, first of all, is going to fail a file integrity monitor, and it's going to actually meet with a known Bitcoin miner for a service context perspective. The second thing is it's actually making calls outbound and mapping that DNS call to TurtleCoin. So, like, we can start to see these things at scale. If you wanted to do further investigation, we're going to roll up all of the different events that are associated with this as well. So you're seeing new external connections that are being established. You're seeing wgets that are happening. You're seeing users launching binaries from an SSH perspective. You're seeing a variety of different things that roll into this event. And once again, if you don't believe the polygraph, you don't believe the pretty picture that we're giving you, all of the other sustaining information in terms of the external connection details, the domain information, all of the other pieces that are actually necessary to investigate this thing, both from a Kubernetes perspective and otherwise, is going to be available to you to actually look at this thing at scale. So to just kind of summarize, there's two major areas that a good security program around Kubernetes looks at. It's going to look at how containers are introducing vulnerabilities when you're building things and as you're actually developing software. And then finally at runtime, actually understanding what container workloads are exposing and kind of the trends around that. And really, Lacework is very well tuned to affect both of those things at significant scale from a Kubernetes perspective. So
Great.
Danielle, I'll turn it back over to you.
Yep. So if anyone has any questions, please feel free to enter those in the questions at the moment. And then Dan, I'll share my screen for the final poll. Once you stop sharing your screen.
Oh, sorry.
Sorry. So our final poll is around what are your greatest opportunities to improve your Kubernetes environment? And while you answer that, we do have one question around, like, alerts can get noisy. So like, how many alerts do customers usually get?
Yeah. So we've seen this across multiple customer environments at this point, and we've done significant study as far as that's concerned. So there's two things that that really affect alerts, right? And the volume of alerts that your security teams are going to be getting. The way that Lacework is designed, we generate about 1.4 critical or high alerts per day per customer. And that's across all of our customers. That's some of the largest customers like Cisco and some of the smallest customers like Polka.io. Like, we generate at about that rate across all of the workloads of protecting, all the CloudTrail logs we're protecting, all of the different things that we're doing within both containerized workloads as well as things like EC2 and regular compute workloads. We're seeing 1.4 critical or high alerts per day. So what's important to understand too, it's not just about the number of alerts that you're getting, but really the context which those alerts are providing. And that's really what's going to compress the investigation time. So the idea is that Lacework generates far fewer alerts, but also provides significantly higher visibility in terms of those alerts, in terms of the number of data points that we're collecting. So it's really important that you understand that it's not just about volume, it's really about how good those alerts are. And the reality is a lot of the rules and policy-based solutions that are out there will tell you that something weird is going on, or some policy has been violated, or some rule has been pattern matched for one reason or another. Those types of technologies and solutions are very noisy, extremely noisy from an IDS perspective, as well as understanding containerized environments. And when you start looking at things at significant scale, particularly in Kubernetes, where you have things that are moving around, developers are going faster, building new services and actually architecting things differently every single day in a lot of cases, rules and policies are really hard to administer at scale.
Mm-hmm. Absolutely. And I know, like, Dan, for us, so Laceworks and Fairwinds has some joint customers where Laceworks is checking the containers, checking to make sure those are secure, and then Fairwinds is working on the other side of the bucket, checking to make sure the Kubernetes configurations are done right.
Yeah, and I mean, there's a huge value there in terms of, like, you got to maintain the guardrails from a Kubernetes config standpoint. You got to maintain certain semblance of reason as far as how you're deploying workloads within Kubernetes. But the idea behind Lacework and the biggest value that we can add around behavioral analytics is the things that fall through the cracks. And the reality is with Kubernetes-based and containerized workloads, you won't be ever able to protect the things that you can't see and the things that you don't know to protect against from a config perspective. So the idea is that Fairwinds actually gets you to a certain point where you have a strong configuration management solution. You have the ability to manage these things at scale in terms of how you're deploying services. But then for the behavioral piece of it and actually assessing the trends over time, that's where Lacework can come in and really add a lot of value to organizations.
Excellent. Well, in response to our survey, for those of you who are with us, 50% of them need to improve their security reliability. 33% need help with the basics, and 17% need a best practice assessment. So it's a good take on where all of you are in this journey.
Great. I think there was one other question. Mohan had another question around the SaaS offering and what compliance certifications we adhere to around healthcare and financial services and all that good stuff. So just to answer that, Lacework is a SOC 2 Type 2 compliant shop. We do annual pen tests. We are very strong, and we have customers that are in financial services and as well as that are HIPAA compliant as far as the healthcare industry is concerned. So we take security very seriously, because at the end of the day, we're a security company. Like, it's inherently important to us that we're adhering to best practices as far as that's concerned. So basically, if you are a SaaS public cloud offering, you cannot do business without SOC 2 Type 2. So if you want more details in terms of what that actually entails around pen testing and how we validate how our agents are built and all that good stuff, I'm happy to give you that as well.
Excellent. So as we wrap, we'll be sending all of you our Kubernetes best practice guide, which talks about security, efficiency of your clusters, as well as how to optimize, monitor, and enforce Kubernetes best practices. So we hope you find that useful. And that is a wrap for today. Thank you all for attending.
Yeah, Thank you very much. I appreciate everyone's time.
Thanks, Dan. That was great.